Okay, so today's video is dihedral potentials, and in the dihedral potentials, we'll look into proper dihedrals and then we'll look into the improper dihedrals. So, what are proper dihedrals? Proper dihedrals are a term for when we are looking a system where four atoms, one, two, three, and four atoms are serially connected through bonds. Then, when we are rotating the bond between B and C, which you can see here, if I just open the laser pointer, so A, B, C, and D, and when we rotate the bond between B and C, let's say A, B, C, and D. So when we rotate the bond between B and C, there has to be some kind of potential involved in this rotation. So that is being shown by the simple periodic function of cosine. If we look closely into the function, there's also a shifter which every pair will have a different value for. So depending on that, the whole curve will be shifted to left or right, and you will have a different kind of potential energy curve for this kind of dihedral torsional angle movements. Okay, so this kind of simple functions are used in MD softwares like GrowMoss. This is not GrowMax. Just mind you, there is another MD tool that is called GrowMoss, and in that tool we use this kind of simple functions. Secondly, when we are using this kind of simple functions, we also have to add the Lennard-Jones potential, which this is acting between first and the fourth atom, and there's a name for it. It's called 1,4 Lennard-Jones potential. So that specifically is made up for this kind of arrangements where four atoms are connected serially. So first and the fourth atom will exhibit some Lennard-Jones potential on each other, and that you have to add to this potential energy curve to get a more refined version which you can actually use in simulations. So that curve might look something like this, as you might be aware of from organics. I think most of you are from chemistry background, so you might have read this cis trans conformation and staggered things, right? In the chiral chapters, I'm sure you might have done that. So what now? So we need to now look at if we, let's say, use a different kind of potential that looks directly like this, and there is no need of adding that extra Lennard-Jones 1,4 potential. We can directly use this kind of functional forms, and this comes from this Fourier transformation of this expansion of this Fourier series. If you expand that, break that, you will get a very big equation, and from that, if you plot that, you will get something like this. So that's another way of representing these dihedral potentials. But just keep this in mind. This Reichardt-Bellemann's equation is being used in GrowMax, and the previous one I've shown you, like the simple curve, that's being used in GrowMoss. So keep this in mind. Whenever you are using this Reichardt-Bellemann's equation, you have to neglect the Lennard-Jones 1,4 potential, else you will run into over biasing. You will be biasing the system because that is already being considered here in this potential. Okay. Now we come into some differences. I think we have already talked about it. You can just go through it. That this is used in GrowMax, this is used in GrowMoss. When to use Lennard-Jones 1,4 potentials and stuff like that. Lastly, coming to the improper dihedrals. So improper dihedrals have two jobs. Firstly, to keep planar molecules planar. So planar molecules could be 6-membered rings like benzene ring or stuff like that, or it could be we could use this potential to keep chiral molecules we can stop chiral molecules from flipping over and becoming their mirror image. So basically, if we don't impose this improper dihedral potentials, then in your system you will see all type of flipping of chiral molecules. So if that's exactly what you want, you can try to switch off these improper dihedrals. That's another way of making the simulation if you really want to customize to that level, right? Again, here we have a very simple harmonic potential where we have a resting angle, and that if we deviate from that angle in any direction, then we will be heavily imposed with like potential energy. So that's basically a harmonic potential. So I think we are done with dihedrals. So we will now move towards non-bonded interactions, Coulombic interactions, and um, Lennard-Jones interactions. So these are the two topics we will cover, and then we will move to other topics. Thank you.